Okay, this is my solution, at least I guess, for quiz number 19. And we are to find the voltage across the capacitor here. And remember, the voltage across the capacitor satisfies this equation. And so if we were to write out what the voltage across the capacitor is, it's going to be the voltage is going to be the final voltage plus the initial voltage minus the final voltage, e to the minus t over tau. And in our case, tau is going to be the Thevenin resistance times the capacitor. Okay. Now, so again, we need to, the idea is to find the final voltage, the initial voltage, and the Thevenin resistance. Okay, so let's do the initial voltage. So before time equals 0, this guy is open. So it's sort of like this part of the circuit doesn't even exist. And so what we want to do is, in this case, everything just charges up. And when it charges up, since I have 6 volts, it's just going to charge up. Once it's charged, it's kind of like this is an open circuit, and so it's going to charge all the way up to 6 volts. So when at time t equals 0, so V0 is just going to be 6 volts. All right, so now we close, to find V final, we close the circuit and let time, basically time go to infinity. And so when I go to find V final, this guy has been closed for a long period of time. And we want to find the voltage here. So after a long period of time, again, current is not going to flow, and we'll just have this voltage. So really, this voltage, V, is going to be this voltage after a long period of time. So we just need to find this voltage. And notice to find when this guy is closed. To find this guy, what I can do is I can combine these voltage sources. So it'll be 33 minus 6, and then I'll have just a voltage divider across here, and so I'll have 6 plus this voltage. Okay, so the idea is after a long period of time, as t goes to infinity, this looks like a 33 minus 6 is going to be 27, and then we'll have 3 ohms and 6 ohms. Okay, and so this, let's just call this V1. So V1 is going to be 27 times 6 over 9. And so let's see, 27 divided by 9 is 3, so this will be 18 volts. And then my V final then would be this voltage, which would be 18 volts, plus this voltage, plus 6, so this would be 24 volts. Okay, so there's my V final. All right, now the Thevenin resistance, the only thing we have to find now is this Thevenin resistance. This is the Thevenin resistance, again, after the circuit has closed. So if I were to close the circuit and then I look back in here, I want to find the Thevenin resistance of that circuit. Okay, so we have, when we do that, we've got notice you've got a voltage source in series with a resistor and a voltage source in series with a resistor. So I could do a source transformations on both of those and then combine, and then I'll have and then do a source transformation back, and then I would have that resistance here. So basically I can convert. Let's see. So I'm going to do a source transformation on the first one. So I'll have a current source in parallel with the 3 ohm, and the current source is going to be 33 divided by 3, so 11 amps. And then the second source here, I'm going to have again a current source in parallel with a 6 ohm resistor, and then this is in series with a 2 ohm, and I want to find the Thevenin equivalent looking in. Okay, and this current source is going to be 6 divided by 2, so it's going to be 3 amps. And this is equivalent to, so 11 plus 3 gives me 14 amps. And then I've got 6 in parallel with 3. So 6 times 3 divided by 6 plus 3. So 18 divided by 9 is 2, so that's a 2 ohm resistor. And then I've got my 2 ohm resistor. I want to find the Thevenin equivalent looking there. So this becomes, a voltage source which will be 14 times 2, 28 volts. And then I've got my 2 ohm in series with 2 ohm. And I want to find the Thevenin equivalent looking back in. So the Thevenin resistance then is equal to 4 ohms. Okay, so that means tau is going to be 4 times the capacitor, which is 0.25 micro. So 0.25 micro times 4 is going to be 1 microsecond. Okay, so now I can write my voltage. V of t. It's going to be the final voltage, which would determine those 24 volts. And then we're going to add the initial, which is going to be 6 minus the final, 24. So we'll have, basically I should write, so we're going to have a 24 minus 18 e to the minus t divided by my time constant, which is 1 microsecond volts. And we should have, when t is equal to 0, let's just check. When t is equal to 0 here, e to the 0 is 1, so we'll have 24 minus 18 should give us 6. Okay, so we recover our initial voltage. And when t goes to infinity, this guy all goes to 0, and so we should get 24 volts. Okay, so we're at least consistent with those things. All right, so there's my answer, V of t.